All right, this is where we left off yesterday. Right? Ready, Ava? You'll get.
Doesn't have a page number.
It's section 2.2. Did you find it? You're at 2.3. That's what we did yesterday. On you. Tisk. We're right there.
Did someone not take their notes just?
It's okay, they're recorded. And you can improve my YouTube status by watching those YouTubes and giving me a like or two. Maybe a shout out, a comment, a follow. All right. All right, here we go. So, did we do D? This is
On the other page?
right here, D. S minus.
Yeah. No, we don't do it.
You were working ahead.
Yeah.
All right, let's start out with D then. All right, Ava, 2 negatives make a positive. So I'm going to change this to S plus 1 is greater than or equal to 2. Now, Nate, how do I get rid of plus 1? Minus 1. So I subtract 1 from both sides, and that gives me S is greater than or equal to 1. And here's what I do, Ava, because I know you work like very similarly the way Mrs. Simonian does. I like to put this number in the middle, where you can put 0 in the middle, and I just go 1, 2, 3, 4, 0, -1, -2. See what I'm saying? And then it's going to be a closed circle at the 1. I'm eating the S, so I'm shading to the right. You okay with that? Katie, you doing okay back there? All right. Now, with E is very different because there's a lot going on, okay? But what I need to do is I need to simplify things down first. So I need to combine like terms. So what I want to do here on the left is combine my p's. -7p plus 8p. So I have 15 plus p. Because 8 minus 7 is 1. Or -7 plus 8 is 1. It is greater than. 15 minus 2 is 13. So this whole mumbo jumbo kind of reduces down to this simple problem. Now, Katie, how do you get rid of plus 15? Take away 15. So we're going to take away 15. And that gives us p is greater than -2. So I go ahead and put -2 in the middle, -1, 0, 1, 2, -3, -4, -5. This is going to be an open circle because of our symbol. And then we are eating the p, so we're going to shade to the right. Now, Grace, I know we have fractions here in the bottom one, but how would you get rid of plus 1/6? Yeah. So we subtract it. Just because it's a fraction, Grace, we don't treat it any different. So 5/6 minus 1/6, that's 4/6. So I have 4/6 is less than or equal to z. Now, 4/6, I'm going to put that in the middle. 5/6, 6/6, 7/6. See how I'm counting up? The numerator's changing. On the bottom, 3/6, 2/6, 1/6, 0. Now, I know 4/6 isn't reduced. I know 6/6 isn't reduced. But I still have my number line that's set up correctly. So I'm going to have a closed circle And I'm going to shade to the right because I'm eating the Z. It's in section 2.2. Nate, following along? Nate, how do you get rid of this? This says -3 is greater than -3 plus h. Add 3. I'm glad you said add 3 and not subtract. A lot of kids will say subtract 3 because of that plus sign. It's all about the -3. So I add 3 and I get 0 is greater than h. So 0 goes in the middle. 1, 2, 3. -1, -2, -3 go to my left. And it's an open circle. And I'm not eating the h, so I'm going to shade to the left. You okay, Nate?
Yes.
All right.
What is it, 2.2? Did you find it, Jim?
Right there. Got it? You doing okay, Kate? You seem like you're struggling. Really struggling? I don't have a pencil. Will this work? It's a pretty green. And with the use of pencil. Ready? Good. Don't worry, it doesn't smell. It's like peach or something. All right. Julie. Now you got to talk to me.
I guess I do.
What's 4c minus 3c?
What?
4c minus 3c. So if I have 4 cups and I take away 3 cups, how many cups?
Oh,
will I have?
C.
What? 1c.
C.
Yep. 1c. So these are going to combine to give me 1. So I have c plus 10. Now, Julie, how do I get rid of plus 10?
Minus.
Very good. So we subtract 10. And that gives us 2. So 2 is less than or equal to c. So 2 goes in the middle. 3, 4, 5. Negative, or not -1. 1, 0, -1, -2. This is going to be a closed circle because of the symbol. It's got a line under it. And I'm eating the C, so I'm going to shade to the right. Last one, Joey. What's 6 minus 9? -3. So I have -3 plus u is less than -2. How do you get rid of that? I can't make it 3u. How do you get rid of that -3 right there? How do you undo -3? No. How would you undo a -3? What's the opposite of minus? So we're going to do +3. Okay, Joey? So we're going to add 3. So that gives me u is less than 1. So we're going to put 1 in the middle, 2, 3, 4, then 0, -1, -2. So it's an open circle at 1. We're not eating the u, so we're going to shade to the left. All good? I'll give you a second to copy that down. The cabinets from yesterday? No, we'll talk about that in a minute. All right. Now, here is why we need inequalities. Now, Ava, have you ever plugged too many things into an outlet and it popped? Do you know what that's called when you like pop the outlet? Yeah, you kind of blew a fuse, right? You didn't technically blow it, but what you did is you set the trip, meaning outlets work where, like any outlet, will send as much power as you want to it, okay? The problem with that is if I keep plugging things into like an outlet, that wire that runs behind it is only so big and it gets hot. So what they try to do is they try to prevent it from sending you too much power and causing a fire in your wall. So they have these things called breakers. Okay, you see them all the time in bathrooms. Because in a bathroom, you plug in your hair dryer, your curling iron, right? All these things. And what they do is they suck so much energy through that sometimes it can start a fire. So they put in these little like switches. When too much current is going through, it pops and it shuts off the current. And it says, hey, you're drawing too much current. You need to be careful. You might start a fire. And let's be honest, what do? You just push the button, you start again, okay? But they put these breakers in there as sort of like a inequality that like you can't go over a certain number, otherwise you could start a fire. And it's a safety feature. So here in this problem, a circuit overloads at 1800 watts, meaning that's when it flips, okay? As soon as you hit 1800, it goes, and it's off. And then all of a sudden, like all your lights shut off and you have to go find out which breaker or you have to push the button. So you plug a microwave oven that uses 1100 watts of electricity into a circuit. So write and solve an inequality that represents how many watts you can add to the circuit without overloading it. So here we go. Ava, how much is your microwave oven? How much watts does it draw? 1100. Plus some remaining watts. We're going to call it W for watts. Is that okay with you? Now, at what number does my circuit shut off? 1800. And it's a hard 1800. Meaning, once you hit that, it's done. Like you can't run it. So this is the inequality that we just created. Now, how would you get rid of plus 1100? Minus 1100. And Ava, what this will tell me is this. This will tell me I can plug something into that circuit that uses less than 700 watts. Now, why am I telling you this? Well, I used to live in, like right outside of Middletown. You guys from the area? Like 352? Anybody? Like High Meadows? No? Do you know what I'm talking about, Grace? You know the shop, right, that they just put in with the Lowe's? I lived back there called Hilltop. And somebody thought it was a great idea to wire, listen to this. I had an outside socket. So any Christmas lights, okay? Think of it like now. My Christmas lights, my downstairs bathroom, my upstairs bathroom, my bedroom and my spare bedroom, we're all on the same circuit. Meaning anything that I plugged into any of those outlets all ran to the same breaker. So when I plugged in my Christmas lights, when my wife was drying her hair with a hairdryer, when she ran that and a TV was on, it shut off half my house. So annoying. So that's why we need these. So we know, hey, is it reasonable to have all these same outlets or circuits on the same breaker? And the answer was no for my house. And I actually had to break it apart and put in a new circuit so that I didn't keep flipping it every year. So for this is in a kitchen. 700 watts is pretty reasonable, okay? You could probably put in the toaster oven and say a blender into the same outlet and you'd be good. But you couldn't run your refrigerator and toaster oven on the same outlet. And that's why they have a specific switch in the circuit breaker downstairs that is specifically for like your heater, your dryer, your refrigerator. Correct, Mrs. Simonian? Because you just had all that work done too.
Yeah.
Now, Ava, since this is your problem, which of the following appliances could you plug in? So you have a clock radio, a blender, and a toaster. Which ones could you plug in? Clock radio and the blender. These two we could plug in. And I can't plug in the toaster because it would trip my circuit. All right, Ellie. Ellie,
Yeah.
Ellie, this one we have the toast, or we don't have a toaster oven. We have a microwave oven. So how many watts does the microwave oven take?
I don't know. Wait, for a microwave?
Yeah,
That's 1,000.
1,000. So 1,000 watts plus some other watts needs to be less than what? And what does at what number does my circuit trip?
1,800.
1,800. Now, let's go ahead and subtract this off to find out how many watts left I can use. Now, can I plug in a toaster oven that requires 800 watts? What do you think, Allie?
Wouldn't it be? Well, I don't know.
Well, why don't you know?
Would it be 1,000?
Well, let's look at it. It says we have 800 watts left. W is less than 800. We have just under 800 watts left. And I have a toaster oven that's exactly 800 watts. If I plug that in, will I keep tripping the circuit?
Yeah.
Yeah, I will. So that means I cannot plug it in. So can you plug it in? No. No, I can't. Because once I do, I hit the 1,800 watts, and that's when it blows. That's when the circuit breaker trips. Tyler.
Yes.
Tyler, you have $15 to spend on groceries. You have $12.25 left, or $12.25 worth of groceries already in your cart. Write an inequality that matches how much more money and you can spend on groceries. So, Tyler, how many groceries do you have in your cart? How much money?
$12.25.
Plus some other amount, right?
Mm-hmm.
And how much money do I have to spend?
15.
15. Now, here's the question. What symbol goes in here? What goes in here?
Equals. Wait.
Is it
Up?
less than or equal to, greater than or equal to? What do you think, Tyler?
Less than or equal to?
Less than or equal to. And I'm glad you said less than or equal to, because we could spend all of my money or not all of my money, but I can't spend more than I have in my pocket. So here I subtracted 1225 from both sides. And what does that leave me with, Tyler? If you spend 1225 of your 15,
Hold on.
what would that be? $2,
$2.75.
$2.75. So you could get like a couple Gatorades, maybe like a power bar and a Gatorade. We could call it a day. All right. Mike. Mike. All right. I'm going to say, we're going to assume you're my friend. Okay?
Yep.
So me and Mike are planning to walk across an old raggedy bridge. The bridge can hold at most 1,000 pounds. The total weight of the people on the bridge are 675 pounds, and Mike weighs 156 pounds. Don't let him fool you. He's pretty husky, okay? So write an inequality and solve it to find out if I can go on the bridge with Mike, okay? So Mike, how much weight can the bridge hold?
At most 1,000 pounds.
At most, which means it needs to be less than or equal to 1,000 pounds. Otherwise, it becomes unstable. How many people are on the bridge, Mike? How much did they weigh?
Wait, what? You just said two different things.
How much do the people on the bridge weigh?
Oh, including 675 or now?
675. How much
Okay,
do you weigh, Mike?
156.
156 husky pounds. And we want to know how much weight can be left to go on the bridge. Now, Mike, what's 156 plus 675?
831.
Let's see if you can do it before me.
831.
831. Now, Michael, how do I solve this? What do I do?
You need to represent.
Yeah, I need to subtract it. What's
Yeah, that.
1,000 minus 831?
It's 169.
What was that?
Negative 169.
Okay, it's actually going to be positive because people can't weigh negative. So, but I know what you mean. So it's going to be 169 pounds. Now, Mike, I'm a solid 182. Lying, no, 182. A little bit more. You know, COVID-19. You know what I'm talking about. So, Mike, can I go on the bridge? I weigh 182 pounds pre-COVID. Can I make it on the bridge? Mike, can I make it on the bridge?
Let me see.
I weigh 182 pounds.
No, you can't.
No, too fat. All right. So Mike and I cannot. No, we can't. No, we can't. And in the words, The Price is Right. No, that's too much. All right. Nice job, Mike.
Thanks, man.
And I think that's yeah, that's probably it. Yeah, that's it. So we'll pick up here. Now,